Thank you. Welcome everybody to the final webinar in our four-part series outlining the results of our Food Hub feasibility study. My name is Matt Keene. I'm a registered dietitian, and I am the local foods program manager here at Cornell Cooperative Extension in Saratoga County. Now, because we've covered a lot of ground in the past three webinars, I want to recap what we've gone over and what we're going to focus on during this final webinar. So if you remember, this study shifted from looking at Food Hub to actually looking at cold chain storage. And we did that because of the entities working in this area. And so in looking at the success of that model, we realized that it was dependent on renting out storage space. So to figure that out, we first had to look at markets. We looked at K-12 in the first webinar. We went over a little bit about institutions in the third webinar. And then we also considered emergency food system a market because they move local food and because they could potentially benefit from staging food for better access for the food pantries. We're considering them a market as well. And also the combination of emergency food system and retail systems to better help food access in rural areas. What we did was overlaid all of these markets onto a map and created these market clusters just to kind of see where everything was concentrated. So we looked at that, and that gave us an idea of where to stage food, because having it close to markets for last mile delivery makes sense from the distribution perspective. Next, we looked at distribution. We looked at the current Food Hub delivery routes operating in Saratoga County and how efficiencies can be created to help farmers get their food to market, including Food Hub cooperation. Between those two, we combined the market cluster map and we looked at the routing map to get an overlay and figure out where would be the best place to stage food for this last mile delivery and also for cross-docking and backhauling as well. So that gave us an idea of locations for food staging. But it didn't give us an idea of where to put these sites for aggregation. So we looked at farmland, and specifically farmland in the North Country, because we wanted to make it so that farmers don't have to drive so far to get their food into this sort of distribution system. That gave us an idea of where to put the aggregation sites. And ideally, all of this would overlap, but that wasn't the case in this specific circumstance. Staging food made more sense down here in Saratoga, and the aggregation made more sense up in the North Country, and we'll go over that with the maps again in a couple more slides. So overlaying that information gave us that idea, but then we noted that infrastructure expansion may need to happen within those aggregation and staging sites. So we have the geography of potentially where to put these and how this could work. Today we'll be going over what the construction of those sites actually looks like. There's a food hub in Albany called Capital Roots. They're right about here. And they did a report called the Greater Capital Region Food System Assessment. And in that report, they noted an increase in agriculture of the middle and wholesale channels as being in the best interest to better serve farmers, underserved communities, and the food system. So focusing on agriculture of the middle is not meant to compete with larger distributors. Cisco and US Foods and Renzi or whoever else, that's not the competition. They work on a much larger scale. This is meant to be smaller orders and smaller distribution than that. And we'll be looking at a modular storage system that can provide organizations with financial and space flexibility. Now, these units require less construction than a traditional cooler or freezer and do not have to be a permanent fixture of the property. So it can be a smaller footprint, it can be flexible, but also there's less commitment. If the containers are leased in a market and that area and that market shrinks, the lease can be canceled and the container can just be taken away. If they are purchased, because they're modular, they could be sold to a different organization, transported to that location, which could help offset the initial capital investment. And all of this is meant to fill the in-between space of organizations that need to expand, either locally or regionally, but can't really justify the expense of renting out a building or outfitting a building themselves. Now, as the markets grow and shrink, these units can as well, not just by transporting existing ones to different areas of the state. to meet that market demand, but by expanding within one site as well, which we'll detail once we go over the architectural drawings. There's a quote I want to go over here, and this is from a paper called Food and Mid-Level Farm, Renewing an Agriculture of the Middle. And it says that farms of any size may be part of the market that falls between the vertically integrated commodity markets and the direct markets. But the mid-sized farms are the most vulnerable in today's polarized markets, since they are too small to compete in the highly consolidated commodity markets and too large and commoditized to sell in the direct markets. So when we're looking at the system, we're looking at the system as a whole as agriculture of the middle. Because as that quote noted, agriculture of the middle is not dependent on size. Farms who are traditionally too small to be considered mid-tier can nevertheless take advantage of the system through the aggregation work of the food hubs. Similar to how K-12 districts pool buying power to access more products, which we went over in the first webinar, utilizing this system provides a way for small and mid-tier farmers to more easily aggregate their products and get it to market. And in doing so, provides market opportunities to growers of every scale, which gets us back to that idea of farmers not having to get big or get out to access these larger markets. Okay, the architectural drawings. As I mentioned, we worked with an architectural and engineering consultant for this, and this was to get an idea of what sort of construction would need to happen on these sites and what does this type of system look like. These drawings, this report will be available on our website. And this is one of the drawings. This is a 100-foot by 60-foot area. And what this shows is this rectangle right here is a concrete slab. This is the loading dock. Now, it is not a raised loading dock. This is just a concrete slab that's on ground level, or have a curb to be just above ground level. This is because we're not looking at having tractor trailers accessing this sort of system. They can eventually, and if that's what your organization is looking at, the loading dock could be built on a higher level, but most of those tractor trailers have lift gates anyway. And if you're talking about farmers who are using box trucks or their own pickup truck, we wanted to have that loading dock a little bit lower so it's easy for them to access as well. Now, this is a covered loading dock, and within this loading dock, there's a little storage shed here. This is for electricity, security controls, lighting controls, that sort of thing. This roof that's over here, which we'll find out later, was put in place for one to make sure that the food coming in doesn't get wet, so it keeps it out of the elements, and also to provide a space to put on solar panels if that is something that would be useful for this type of site. This is another drawing, and you can see that the concrete slab was shifted back just to kind of show that there are different orientations that these containers can take. So you could have this 8-foot by 40-foot container attached on the side, another one over here, and you could have a third one right here if that's how you wanted to organize your site. And one thing I want to note with this is that these dotted lines are partitions. Because if the idea is to rent this out to multiple organizations, there needs to be some sort of a warehouse worker or whatever you would like to call it on sites to help unload, but also to help make sure that everything stays safe and that there's no accidental tampering or damage happening to other people's products. So that person would be there to manage the warehouse, but also to make sure that everything is staying where it should and to prevent any sort of damage from occurring. This is a side view of the site, and you can see this is that storage shed that houses the electrical equipment and such, and then the potential for these solar panels up here. This one down here we will get to in a minute. This is what we're going to call a cooler shed. And I bring this up just because it will come up during the revenue and expense portion of this, just to know that there's another option for this that we're looking at, and this is the view of that being attached to the back of the loading dock. These are pictures from a brochure of a company that we worked with just for purposes of estimating costs and infrastructure requirements. Now, there are many companies who lease and sell refrigerated containers that work in a similar fashion. This is just the one that we used for the purposes of estimating the expenses. And I mentioned before that these modular systems can grow and shrink to fit the market. And I mean that literally. This picture here, you can see there's about three or four of these containers linked up together. How these work is if you wanted to expand, say you start off with one container and that container can't really accommodate a forklift or a pallet jack. You can fit one in there, but if you're working with full pallets, they have to be lined up and it would be difficult to access anything in the back. So if you get to the point where you expand and need to be working in full pallets and not just broken down pallets, you could purchase or release another of these units, and then what happens is they take off the side of two of them and then match them together, and you can continue to build on that. So as I said, it can grow and shrink as your market and as your needs grow and shrink as well. And then this one I want to point out because it looks like they took a container and just kind of put it on its side and then have larger containers going off the back of it. And if you note, there are two doors for access right here. If you have an organization that has enough volume to rent out an entire trailer, this is a way to keep your site consolidated while still providing that security, because there are two separate doors for these two separate containers. And that means that you don't have to worry about having any sort of partition between different sections if you didn't want to go that route. Now, as I mentioned, we discussed options for infrastructure placement in the last webinar, and I'd like to refresh everybody on that briefly. We created these maps noting where the current food hubs are. So this is 80K Food Hub in Tupper Lake and Hub on the Hill over here in Essex. And we did this line for a 1-hour drive time just to kind of see what farmers could easily aggregate with these two hubs. And we found that in doing that, these hubs missed pretty much the entirety of the farmland in the North Country, which is up here. And so by doing so, thought that, well, if we have these aggregation sites, what I mentioned with looking at the farmland and trying to find the, kind of a central location for this, we have these aggregation sites that makes it easier for farmers to just drop to this site, which is already connected to an existing route for 80K Food Hub. And 80K Food Hub is already on an existing route for Hub on the Hill. So this is a way to, what we mentioned last webinar, connect the pieces of these different distribution systems to make this food flow more easily out of one area and into another to try to access larger markets if that's something that the growers in the area are actually interested in. Hub on the Hill then goes down I-87 all the way down to Albany. If you meet up with Albany, that's I-90, and you can go east-west throughout the state as well. Now, Saratoga Springs is about a half-hour north, 40 minutes or so north of Albany. And when we looked at these route overlays, we found this corridor between Schuylerville and Saratoga Springs where 4 food hub routes meet up, which is why we are suggesting that this is an ideal location for having one of these staging sites. And as I mentioned in that first slide of the aggregation points and the staging points maybe not matching up, having these 3 sites could be a way to aggregate the food up in the North Country and funnel it down the 87 corridor for further distribution throughout the state to help open up those markets for food hubs and those growers as well. Now, working from the idea of having no more than a 2-hour round trip for farmers to get their food into circulation, I created a map of aggregation and staging points throughout upstate New York. Now, these points are based purely on geography. They do not consider the food system work being done in each of these areas by various organizations. This is purely meant to show the amount of potential sites needed throughout the state to cover the farmland. And this will come back again when we go over the investment necessary to roll this type of system out to the entire state. Now, these are the potential sites. There are 8 of them placed around the state. And we brought in also the existing sites. So these are existing food hubs that are outlined in purple here. And you can see that on the eastern side of the state, it looks like there's a lot of overlap. And there is a lot of overlap. And this is where the distinction between aggregation points and staging points come in, where you have comfort food and capital routes here that theoretically are a good aggregation point because they cover a good bit of land. But looking deeper into what's going on in that area brought us to the realization that because these 4 different food hubs overlap there, that would be a good spot for staging of food. And I imagine this would happen in any area that you're going to study that something that on the surface looks like it shouldn't, it might not make sense, having these three in one area. When you dig down deeper, it might make sense in the larger picture. And then we also talked about this having SUNY campuses as potential sites as well. The benefit of that being there are food pantries on just about every single SUNY campus. So the food pantries could get better access to local foods. The dining services could also get better access to local foods. And this could act as a cross-docking or staging point for other areas depending on where they are. We also talked about having rural grocery stores as potential staging sites as well. When in that second webinar, we spoke about the potential for grocery store delivery out to those areas that were noted as low income and low access. So you could help with food access in that way and also potentially serve as an aggregation site for any farmers in the area and that sort of staging and cross-docking site for the food hubs. So that's what the system looks like. Now we're going to go over what this type of system would actually cost. As I mentioned, we worked with an architectural and engineering consultant for this aspect of the project. These numbers are taken from their final report, which is available on our website. Now, option one covers construction expenses. And you can see here, they laid out what that would cost. And you get to a subtotal for construction costs of about $61,000 to create that loading dock, the storage shed, and all that. And then, considerations for the contractors and what they would be paid. You come to about $82,000 for the construction work of the site. We further broke that down to look at what would the expenses be without the site work. If you have a site that's more developed, something like a SUNY campus where you don't have to purchase the land is pretty well developed. If all you wanted to do was drop a container there, you might have to run an electrical line, but there might not be much outside of that. We kept in the concrete work and the loading dock construction to come to a total with all the escalation and everything of about $36,000 for construction costs. Now that's option one. Option two is what I mentioned before with that cooler shed. Now this is a pre-manufactured shed that has been outfitted to be a cooler or freezer inside. And the reason we looked at this is that in the Adirondack Park, there are aesthetic requirements that wouldn't necessarily be met by just having a trailer, like 40-foot by 8-foot container on site. There would be extra construction costs to hide or otherwise make the thing look nice. So instead, we looked at this sort of pre-manufactured building because any sort of construction and outfitting involved with a pre-manufactured building means that if this were to move, that can move with it. So if it were to move to a different site in the Adirondack Park, the aesthetic requirements are met instead of having to build an additional, whatever the thing would be to try to meet those aesthetic requirements. That pre-manufactured building came in at about $48,000. For purposes of monthly estimates, we're not looking at option two. We're only going to be looking at option one. So really, we're just taking the total for the construction expenses and adding on to that the total for if you were to lease or purchase one of these containers. Now, with the layout of the loading dock, there is space to fit 20 solar panels. This table shows the output and estimates the expenses of a 20-panel system, keeping in mind that the containers themselves also have the option of including solar panels on the roof, so you could get a larger system than this. And depending on the site, there could be options for additional solar panels that are freestanding. One advantage of this is that it can provide flexibility for the owner, even if that modular freezer is moved for whatever reason. Because New York State does not pay for kilowatt hours produced from solar panels anymore. The price they paid was notoriously low, and it just wasn't really working out in people's best interest. What they do now is any generated electricity over what you use is put into essentially a credit system, and they keep those kilowatt hours. So instead of paying you for the kilowatt hours, they just kind of hold them in reserve that you can then apply to later statements if you need to. So if it's winter and I am 100 kilowatt hours for the month below what I generated, I could then go to that bank and apply that to those 100 hours, and I wouldn't have to pay anything on that. So even if this were to move, this sort of electrical generation could be applied to other expenses on that owner's property. Now, to go over the system specifically, this is a 20 panel system, which would give an output of about 12,775 kilowatt hours per year. We looked at Saratoga, Jefferson, and St. Lawrence County and the expenses associated with actually putting in this type of system up there. We looked at those three because those were the three counties where the aggregation sites and where the staging sites were noted. And we took the highest one here, 314 per kilowatt hour for installment. And with the federal tax credits, the total for that is about $28,000. Now, assuming you're not going to buy that outright and you're going to lease it, excuse me, not lease, but loan, take out a loan for that. The loan term that we used was 5 years, 8.5% interest, and 10% down. At that rate, that would be about $517 a month. And that offsets about half of the electricity needed for the running of one of these containers. So it would essentially cut your electric bills in half. The new electricity cost would be, after the solar panels, is about $246 a month. And this sort of system would take roughly 11 years to actually pay for itself. I'm not going to go through the entirety of this sheet. Could you please mute yourself if you're not already? So I'll just go over what this sheet is displaying. I'm not going to go through every single number. On the left, we have what I'm looking at as option 1, which is if you have these containers, you leased them instead of purchased. On the right is option 2, which is purchasing the containers. Now, we took the construction cost, which is kind of the same. We took into account the lease versus the purchase. Excuse me for a moment. Can you please mute yourself if you're not? Thank you. And then we looked at labor. As I mentioned, there would have to be some sort of worker on site to help unload and to help make sure that all the food is safe and there's no damage being done. For that, we considered that person a 0.25 FTE at about $60,000 a year. So that's where their labor cost comes in. Now, if you were to lease, your total monthly expenses would be about $4,100 a month. If you were to add in the solar panels are down here on the bottom part. If you were to add on the solar panels, that's about $4,300 a month. If you're looking at purchasing, the total would be about $4,000 per month. If you had the solar panels, about $4,200 to $4,300 a month. Now, we also broke this down if you don't need to do as much site work, so keep that in mind. And all loans associated with this purchase are assuming 10% down, 5 years, and 8.5% interest. For potential revenue, we use the lower amount of revenue available here to kind of do a worst case scenario for what monthly expenses would look like. So we're taking the highest cost and the lowest revenue to get that worst case scenario. And in this case, the company that we worked with, they have 3 different size containers, 8 by 10, 20, and 40. And for purchase, we only got the revenue or the purchase requirements for the 8 by 40. So I don't know what the 8 by 20 or 8 by 10 cost. But I wanted to break down exactly what you'd be able to put in these and how much revenue that could generate. This is just looking at one of these containers. Now, as I mentioned, the 8 foot by 40 foot one, you wouldn't be storing full pallets in that. That would be a size container where you would have to break it down. And then you would have a shelving system that kind of makes a horseshoe around the perimeter. Using that type of system, we're looking at a shelf that's about 2 feet deep, so 2 feet away from the wall. And then you would have 4 shelves that are 2 feet apart. That would give you a total square footage of 631 feet within that one container. And then we need to figure out how many pallets can that fit. For that, we're looking at just a standard pallet size, assuming that that pallet is stacked 3 boxes high. If you're using both of those as estimates, you could fit roughly 15 pallets in one of those containers. So from there, we looked at what is the market rate for cooler rental and freezer rental. And we came up with about $250 per month for cooler, which would give you a gross revenue of $3,750. and then about $400 per pallet per month, which is how these rentals tend to work just from looking at industry standards. And that would give you about $6,000 in revenue per month as well. And then from there, we wanted to see what's the break-even point of this. Can you actually rent out enough space to cover expenses while you're paying for your loan and then after the loan is already paid off? So the top part here is what this would look like while you're paying off the loans. The bottom part is what it looks like after the loans have already been paid off. Option one, again, is lease. Option two is purchase. So option one, you're spending anywhere from $4,000 to almost $4,300 per month, depending on if you have solar panels. Now, if you're using it as a cooler, it won't break even if you rent out the entirety of the space while you're making those finance payments. So that would be a money sink. Now, if you're renting it as a freezer, because the freezer comes with a higher premium for rental space because you're using more energy, you would have to fill 68 to 73% of that space to break even. If you go over here to purchase, it's pretty similar. That the cooler won't break even. That would cost money month to month, provided that you can even fill it entirely. But if you're doing it as a freezer, you're looking at 66 to 71% required rental space to actually have that break even. But then after finance payments, now there's a discrepancy here because in the lease option, that lease just continues. You have to keep paying that, forever. But if you purchase it, those payments go away after 5 years. So the lease option, you'd still be paying $2,500 to $2,300 a month, depending on if they're solar panels, after all the construction costs are paid off. If you're looking at purchasing, you're only paying $1,700 to $1,500 a month, again, depending on if you put solar panels on it. Now, looking at that, if you're leasing, the cooler will break even after those finance payments are done, with about 69 to 62% of the rental space actually rented out. A freezer, however, will break even at 43 or 39%. And then if you look at the purchase option, if you put on solar panels, if you are using this as a freezer, you only need to rent out 25% of the space. If you happen to rent out the entirety of it, you're looking at a net profit per month of about $4,500 for one of those containers. There were 8 sites noted throughout the state in that map that we looked at previously. And those sites, again, were based purely on geography and not the realities of the food systems within those areas. So we wanted to look at what would this cost to roll out to the entire state. Assuming everybody needs to do all the construction expenses and looking at just one container per site, it comes out to just shy of $1 million. And that $1 million would allow for that flexibility and also give 120 pallets worth of space that would be spread out throughout the state. If you're looking at having 2 containers per site, that would cost just shy of 1.3 million and allow for 240 pallets worth of storage space throughout the state. Now, not every site will need this much storage space, and there can be more sites than this noted. If the system were to incorporate smaller sites elsewhere to serve those markets as well, think of the rural grocery stores where you might have a smaller container that's not really part of that larger picture, but could be an important link for that local food system. And if you remember, I mentioned that all of these numbers are assuming 10% down payment on all the loans. If more is put down, the loan amounts will decrease. A better solution is obtaining grant funding for this. However, the main food system grants available through the USDA, which are the Local Food Promotion Program grant and Regional Food Systems Partnership grant, don't allow for this sort of capital investment. It's too expensive per unit to be an allowable cost within those systems. And many current grants pay for the purchase of local foods. And while that is important, that does nothing to create a self-sustaining system. That sort of system requires a constant influx of money. And physical as well as administrative infrastructure is needed for these types of systems to perpetuate. And I consider administrative infrastructure the coordination, the relationship building, and pilot studies like this project. And while that is an important aspect of this, all the studies and connections in the world won't matter if there's not enough physical space to actually store enough food that results from those administrative activities. Now, in New York State, Ag and Markets is looking at making some funding available for this sort of infrastructure buyout. I don't know what these numbers will end up as. I don't know what this sort of program will look like, but at the moment, they're looking at about $10 million for this infrastructure. So to outfit the entire state with this sort of modular flexible unit would cost about a tenth of that. Since the idea is to expand the cold chain, we also need to look at the cold chain in more detail to see what the benefits are and aspects of refrigeration in general to consider when looking at cold chain expansion. A major benefit of the cold chain is spoilage prevention, and with that, a subsequent reduction in foodborne illness. Now, we spoke about emissions from the food system in the last webinar, but we didn't really touch on emissions from food waste. Globally, food loss accounts for 3.3 billion tons of CO2 equivalents per year. And if that were a country, that would be number 3 behind the US and China. In the US specifically, 40% of all food is wasted. That's roughly 119 billion pounds of food worth about $408 billion. Now, food waste happens at every point along the process, from growing and harvesting to transporting, storing, and the consumption process. But a number as large as 40% suggests that a more efficient storage and distribution system, like the one outlined last week, and greater cold chain coverage could help to prevent those losses. Now, there's a study that I'll be referencing throughout this section. It's right here, it's called The Potentials of Greenhouse Gas Emissions Reductions from Cold Chain Systems. That study notes that the US has a 95% cold chain coverage rate for meat, milk, and aquatic products. Processed or fresh produce was not considered in the study. However, produce obviously helps to contribute to food waste. Now, this study also only looked at the macro food system, not individual areas. So it looked at the US as a whole. Local food systems did not factor into their equations and estimation of cold chain coverage. So while they show 95% coverage of the cold chain on a macro scale and for certain products, local realities may be different. They also noted that, this was noted from the USDA, that equipment malfunction as a contributor to food loss as well. So at the retail level, but also elsewhere. We had coolers and freezers malfunction and breakdown when I was working in the Saratoga Springs School District, and you unfortunately get food loss just from that too. There are a couple quotes I want everyone to remember as we go through this section. These were published by the USDA on food waste and emissions. And in that article, they noted that the EPA estimates that each year, US food lost and waste encompasses 170 million metric tons of CO2 equivalents. They also said that this estimate does not include the significant methane emissions from food waste rotting in landfills. So food in a landfill is not exposed to oxygen, and because of that, it undergoes anaerobic breakdown. Anaerobic breakdown creates methane, and methane has 28 to 84 times greater global warming potential than CO2. And what that means is that for every molecule of methane that's emitted, it's the equivalent of emitting 28 to 84 molecules of CO2. This article also goes on to state that 24% of landfills are food, and 22% of what is incinerated also are food products. So if we're looking at trying to reduce food waste, the EPA has a food recovery hierarchy, which is on the top left here. And it details what to do with surplus food from most preferred to least preferred. Now, surplus food is a major source of food waste because if it can't be repurposed in some way, it'll just end up in the landfill. And this is going through how to repurpose it. The first one is not repurposing. That's just try not to order as much, try not to produce as much if at all possible. If that's not possible, then we go down to feed hungry people, feed animals, industrial uses. Basically, use it in some way that can benefit everybody. If you can't do that, then you can compost it. And if you can't do that, then it will go in the landfill or the incinerator. And the reason that composting is down here is that there's a lot of energy that gets put into growing the food, and those calories are meant for consumption. If we just put it back into composting, you can put it back into the soil, which is nice, but all of that energy that was used to create those calories is now just gone. The next two images are from the Capital Roots report that I mentioned earlier. Now, the one in the middle looks at feeding hungry people and breaks down the most beneficial and most cost-effective way for growers to do that. So again, most preferred to least preferred. Think of this as a more detailed look at feeding hungry people. The first thing that they say to do is essentially sell it somewhere else. These top three are sell to somebody else if you can. The bottom two are donate it if you can't find another market to sell this to. The donation process can be a little cumbersome, which is why I imagine this is on the least preferred, because it would require more work on the part of the farmers. Now, the one on the bottom right further details the donation hierarchy. So if no other markets are available to sell to, then donate it. This last hierarchy may have changed with the Nourish New York program. That program was not in place when this report was made, so it might be different if you were to look at it now. Now we can see the importance of reducing food waste from an emissions perspective, but also from the grower's perspective. It's easier for growers to have markets to sell to than to have to find another market or go through the donation process, which is why the market expansion piece of this is also important, because that can help reduce food waste when there's a more robust market to sell to. Making it easier for farmers to access these larger markets through the cold chain infrastructure and distribution efficiencies that we detailed in the last webinar is a way to help prevent this food waste. We looked at how food waste contributes to greenhouse gas emissions and the importance of cold chain coverage in regard to reducing food waste, but how does increasing cold chain coverage itself actually affect emissions? So going back to that study I mentioned at the beginning of the section, they estimated the increased energy use of greater cold chain coverage compared to the reduction in emissions from food loss and came up with the total. So this one is specifically for milk. You have China over here and US here. Those are the two countries that they studied. And what they look at here is the current emissions from milk just with cold chain coverage. And you can see that this is the emissions, this green bar is the emissions for energy production. This gray bar is the emissions that come from food waste. That's what we currently have. Then they looked at an optimized model and saw that, well, the emissions from energy does increase quite a lot, but you also decrease emissions from food loss by a lot as well, and it results in a net decrease. Now remember, this is only looking at energy use, not refrigerant gas manufacture or use or leakage. And with New York State's goals for a renewable energy grid, these energy emissions could be even lower, resulting in even less emissions from cold chain coverage. Last week, we also went over New York State's electricity generation. And this chart shows the electricity generation for the New York upstate subgrid. This information was found on the EPA's Power Profiler site, which I've linked here. So when I send out the slides, you'll be able to look at this as well. And on that site, you can select and see the area that your subgrid covers. It also details what is actually one of the methods used to produce the energy in that area and the emissions of each subgrid compared to the national average. So this right here is the New York upstate subgrid. And you can see gas makes up about 26% of our generation, specifically in upstate. This little blue line here should be gone now because the last coal plant closed in 2022. The majority of the rest of this, roughly 74%, is done through, for the most part, renewable means. Again, that's if you consider nuclear renewable fuel, but there's a lot of hydro, some wind, but for the majority of it, gas is where most of the emissions come from. So New York State, on average, the New York State upstate subgrid specifically, produces 27% of the national average for CO2, 2.8% of the national average for sulfur dioxide, and 19% of the national average for nitrous oxide. But electricity generation is only part of the picture with regard to cold chain emissions. Refrigerant gas is also a powerful greenhouse gas, and expanding the cold chain requires expanded use of refrigerant gases. Now, this study mentioned that 43% of energy use in the retail sector is from refrigeration. And greenhouse gas emissions from retail increased 360% between 1990 and 2015. Now, a 360% increase in emissions suggests an expansion of retail refrigeration, and without a greater volume of foods that require refrigeration, that expansion is unnecessary. A similar expansion in the volume of vacuum sealed foods, especially if they replace frozen food varieties, may decrease the need for refrigeration at a retail level. And in considering what we want the food system to look like, is it more beneficial to focus on shelf-stable products like vacuum sealed and canned foods? Or is it more beneficial to focus on the cold chain? Keeping in mind that not every food lends itself well to the canning or vacuum sealing process. Preserving food in that way will also help prevent foodborne illness without requiring such energy intensity after processing. Storage costs for this will also be cheaper since they don't require refrigeration. Now, this is an issue that was contemplated in doing this study, but not gone into in depth. This is something that I'll speak about again at the end, but this would be something for further research. Now, getting back to refrigerant gas, the EPA is about to begin a phase out of widely used refrigerant gases that have a high global warming potential in favor of ones that have a lower one. One of these gases is called R404A. Most refrigerated units use this gas. Now, I mentioned the CO2 equivalent of methane earlier being between 28 and 84 times that of CO2. This gas has a CO2 equivalent of 3,900. So it's an incredibly powerful greenhouse gas. And a recent study showed that if supermarkets were to switch from this gas to a lower global warming potential gas, it could cut emissions from the refrigerated systems in half. And that's considering how that energy is produced, or how the refrigerant gas is used in the first place. So cutting emissions by half just through the refrigerant gases, but then also cutting emissions through wider cold chain coverage, and the greening of the grid in New York State could drop emissions a lot more than that. This is the chart from the EPA showing how these gases will be phased out. Less of it will be manufactured as the years go on, which typically means it'll be more expensive. By 2037, 85%, the manufacture of this gas will drop by 85% from its current level. Now, any refrigerated system that's purchased today will be 14 years old at that point. Remembering back to refrigerator malfunction affecting food loss, we have to think about the long-term cost of expanding the cold chain. And in doing so, we should also consider the maintenance cost of these systems as the refrigerant gas becomes more and more expensive. And also the cost in lost product and emissions from food waste. Because if a system is more expensive to maintain, it may not be kept up as well as a system that's less expensive to maintain. So when speccing any new system, the question should be asked of whether a system designed for the new gas or one designed for the old gas is in the best interest of your organization, both financially and environmentally. From what we've found through this study, expanding the cold chain with this modular system serves both the financial interests of those who make up the food system, as well as environmental interests. But there's still some unanswered questions. And that goes back to the vacuum sealing. So do processing and storage efforts want to focus more on shelf-stable items than frozen? And what are the energy and emissions effects of that? That, as I mentioned, there's much lower energy input from processing foods to be shelf-stable than if they were to be processed to be frozen. Even though emissions would appear to drop from the expansion of cold chain infrastructure, especially given New York State's electricity generation goals, and from the decrease in food waste, the question of how taxing this is on the future grid should also be considered, and looking at that in consideration with New York State's goals for electric vehicle coverage as well. So is less energy intensive food storage a better option in the long run? Then the question of plastic generation with these vacuum sealing bags comes up. There are compostable bags available, but they're expensive. And would an increase in vacuum sealing throughout the industry allow for price decrease through volume, similar to the Urban School Food Alliance and what they did with compostable trays, again, which we mentioned in the first webinar? Another unanswered question is vacuum sealing better for displaced populations, both at home and abroad? Shelf-stable items are much easier for homeless and refugee populations to use, and shelf-stable items are easier to ship and hold, allowing potentially for a better response to crises that cause displaced populations like hurricanes and floods. And then, can both frozen storage and shelf-stable processing expand together? Can there be a larger emphasis on shelf-stable foods and a smaller emphasis on frozen and chilled foods, knowing that both serve a purpose? All of these are questions to consider when looking at infrastructure build-out and the direction of the local and regional food systems. So what we were able to determine through this food hub feasibility study is that cold chain expansion can show a decrease in emissions and food waste while providing benefits to the local food system and the food system at large. All of this can be done through a relatively simple and cost-effective solution. And by coordinating with local and regional food systems efforts to link together distribution and storage systems into this larger picture, and by growing markets for local foods, we can positively affect every industry that utilizes and makes up the food system. And while doing so, we can also decrease emissions domestically and abroad, provide greater food access for underserved communities, and allow for flexibility within the system that can change and shift as needed, all while maintaining the autonomy of local and regional food systems. And that for a price tag of $1.3 million in infrastructure, if it were to be rolled out to the entire state. Keeping in mind that we estimated 8 geographic sites throughout the state for this type of expansion. And we noted that Saratoga County as being particularly well positioned for one of those sites. Utilizing the methodology that is on this slide and what we've gone over during these past 4 webinars can help other regions refine their view of cold chain infrastructure placement. Now, we are hoping to pilot this idea in the North Country and the Capital Region of the state through a regional food systems partnership grant that is still yet to be awarded, but we're hopeful. That grant will bring together a multidisciplinary group that includes representatives from every aspect of what we've discussed these past 4 weeks. This work will be done in conjunction with growing market opportunities for farmers in those areas. And the last thing I want to leave you with is my hope is that this work can further the efforts for a comprehensive view of the local food system. There are many different ways to look at these issues, and this is just one, which is why greater cooperation among all of these industries and amongst each other is important to bring together different perspectives and create a food system that works for everyone. Thank you. If there are any questions, I would be happy to answer them now.
Thank you, Matt. This was amazing. So it really is important to take the idea of food system seriously, and you've done a great job of that here. I think it's easy to overlook things that don't sound glamorous, but I think this is really the type of work that's going to get us where we need to be in terms of the food system and combating climate change. However, systems get really complex and interconnected quickly. And so my question was just how you decided what things are worth considering when you start to think about refrigeration and the effects of the refrigerants, of food composting, all of that. How did you figure out which variables you needed to look at for that?
Well, these are not all of the variables either. As I said, this is just my
Right.
perspective, so that there's all kinds of stuff I'm sure that I'm not considering because this is just me. But these were just questions that came up while I was digging into this work and looking at, well, okay, this accounts for the electricity use, but it doesn't account for refrigerant and what's happening with refrigerants, and noticing that the EPA is going to be decreasing this. And also, and I think this is where the multidisciplinary part of it comes in, spoken to a lot of people who have a lot more experience in different aspects of this field. Like I spoke to a friend of mine who he teaches HVAC at a community college out in South Dakota. And I asked him about these sorts of things because I'm not overly familiar with it. And he is the one that pointed me in the direction of those like the EPA and the reduction and how this whole system works. And he's also looking at the climate impact of that. It was more just the questions that came up during research that I felt warranted going down a little bit of a rabbit hole. The food systems, um, the second webinar, the food systems webinar, or excuse me, food access webinar, that entire thing was a rabbit hole because all I wanted to do was note where are the low income and low access communities so we could figure out how to incorporate those communities into this sort of this structure that we're looking at. But then coming across the USDA's map and saying, well, that doesn't seem to really capture what we're looking for. And then going down the rabbit hole of what's the methodology that they use, and is there a way to refine that methodology to find these communities where we would otherwise miss them? So really, it's just like trying to ask the right questions and figure out, well, can we get an answer to this right now? The vacuum sealing one came up later in the process, so that's one that I left for further research.
Fascinating. Thank you.
Yeah. Anyone else? Any other comments or thoughts, or if anybody thinks that this might inform or impact the work that they're doing? Well, if there are no other questions, then I suppose we can end it there for today. And as I mentioned before, if I'll be sending out the recording soon, and then we will also be I'll also be sending out